Okay, so today is our first lecture. As you can see, the topic of the courses or the name of the course is Bridge Design with CSi Bridge. So as I said previously, we will be covering most of the our focus will be on the software version, and we will also discuss some basic theory while proceeding with the software. But our main goal of this course is to discuss the software modeling and designing of bridges with software, and we will be discussing mostly the uh, RC type bridges, because for pre-stressing design and modeling, you guys should also have a prior knowledge of pre-stressing, and it is not feasible to cover all the things in this. Hopefully, we will offer a course in future which will solely be related to pre-stressing. We will discuss some part in this course as well in the end if we have some time. So I will try to cover as much as in the first week, because in the second week we will have some advanced topics. So the course may proceed in such a way that we can cover one or two lecture in one class, and maybe a single lecture in two classes in two sessions as well. We will try to complete this course in 10 sessions, but if it takes a session or two extra, then we will take it. We do not have problem with this. So today is the first lecture. It is about introduction. So the basic introduction is that we will start with bridges. So what is bridge? So these are some of the definition which I have taken from some of the sources. So a structure spanning and providing passage over a river, a chasm or road, or the like, a structure carrying a pathway or roadway or a depression or an obstacle, a structure that is built over a river, roadway or railway to allow people and vehicle to cross from one side to another. A bridge is a structure that is built over a railway, river or a road so that people or vehicle can cross from one side to another. A structure carrying a road, path, railway, etc., a river, road or other obstacle. A road, railway or a path that goes over a river or another road and structure that support it. A structure spanning and providing passage over a gap or a barrier such as a river or roadway. So all these are different definitions given in different resources, but none of them is complete in one sense or another. So these are some of the definition, but you guys have also have a prior idea of what a bridge is and how it works. I think someone mic is open. If they can shut it down, so it is disturbing. I'm not accessing it, so please shut down your mics, okay? So these are some of the classification of bridges. So there are different classification based on uh, different usages or different materials. So we can have bridges for road traffics. So you can see this is a road traffic bridge. We can also have for rail traffic. So this is a rail traffic bridge. Non-motorized traffic, for example, for pedestrian and cyclists. So this is basically a cyclist bridge for cyclists. And we also have bridges for other structure as well. We can have aqueducts and canals. So this is a bridge for, this is an aqueduct. So an aqueduct is basically an elevated, you can say, water carrying structure. This is also a bridge that is used for carrying transmission lines. So this is a very a new thing. So there are also different type of bridges based on typology. So we have girder type of bridges. So you see this is a girder type of bridge, sorry. This is also a girder type bridge. We have truss bridges. So this is a truss type bridge. Arch bridges. So this is a typical arch bridge. Suspension bridges. So this is a suspension bridge. Cable stayed. This is a cable stayed bridge. Extradosed and hybrid. So you guys may have heard the name Extradosed previously or not. So Extradosed are these type of bridges. These are basically frame type bridges, but they are somewhat an externally post tension bridges. So these look like typical cable stayed bridges, but they are not cable stayed bridges. They are of another class. And we can also have hybrid bridges in which we can use both the suspension and cable stayed, a combination of suspension and cable stayed. So as you can see in uh, this picture, this you can see this is a hybrid bridge. So you see that the spans at near the support are cable stayed, but the mid span is a suspended span. So we can also use a hybrid type of systems for if depending upon the situation, depending upon the available site condition. So based on material, we also have different type of bridges. We have masonry bridges. So this is a masonry bridge. We also can have timber bridges. This is a basic a pedestrian arch bridge, which is made from timber. Steel bridges. This is a steel bridge. An iron bridge. This is an iron bridge. Concrete bridge and composite bridge. So this is a concrete bridge and this is a uh, um, composite bridge, in which we can see that the end part is of concrete and the mid part is made of steel. Okay, my sound is uh, clear. Does anybody have problem? If they have, so they can ask, they can poke me during the lecture. Okay, thanks. Okay, so coming to the basic philosophy of how these bridges works. So this is a typical, as I showed you this, let's this bridge. So you can see that this is a basic a variable depth bridge. So what is the purpose of using these variable depths? So these are basically done to provide economy and efficient designs to save materials. So you can see that this is a simple continuous beams in which we have negative moments at the support in such type of structures. So if you guys have any analyzed such type of beams or such type of structures, you might have observed that at the support we have a lot of negative demand coming. So this uh, this concept is used for the variable depth. So we provide higher depths at this location, and so at these points we provide mm, greater depths to support these high demands, and at mid depth we do not have their demands. So the girder is proportioned based on the demand coming from the superstructure loads or the structure loads. So you can see that how these how these shapes are modeled. So the main idea philosophy behind these shapes is the demand and the efficiency of the structures. This is an extradosed bridge. So these extradosing is also this, and this works the same, but in this type of bridge the cables are working as an external post tensioning. We provide a higher eccentricity here to support the negative demands. So you can see here this is a typical extradosed structure. This is an extradosed structure. Let me show you the extradosed bridge again to So this is a typical extradosed bridge. So you see that there is a difference between the extradosed and the cable stayed bridges. Uh, Let me show you the cable stayed bridge. This is a cable stayed bridge. You can see that the angles are not very steep, but here in the extradosed bridge, the angles are very steep. So these bridges work differently from the cable stayed bridge, and how they work. So they work like this. This is a typical cross section of these extradosed bridges. You can see, and this is the pylon, or you can say the support. So normally what we do in the pre-stressed bridges, that we provide an eccentricity somewhere around here, and the applied demands are resisted by this eccentricity and the compression force coming from the pre-stressing. But in extradosed, what we do, that we shift these tendons from here to there. So we provide a higher eccentricity. So what this higher eccentricity to do, this resists the couple created by the demand. So this moment is resisted by this P and E P and combination of P and E. This Extradosed is a very latest addition to the bridge directory, and it was invented in 1980, 1981 in Japan, and this technology is now widely used for these frame structures. So it is basically a frame bridge, but a frame bridge with an external post tensioning. So you can consider this Extradosed and a frame structure with external post tensioning. If someone want to study in detail, so they can use this guide for the behavior of these bridges. This is a typical truss bridge. So in truss, the loads are coming from the structure above, and these compression and tension in the bottom and the top members provide the resisting couple, and these strut transfer the force between the top and the bottom. This is a basic. This is a okay. So this is a schematic of a truss bridge. So how the truss bridge works. So in the truss bridge, what we do, the engineers do, that they provide a propped cantilever type of structure. So the first span is an anchored span, and the second span is a cantilever span. So one span, such span, comes from the left, and the other comes from the right, and they provide a suspended span here in this in between. So this is how the structure scheme works. Let me show you a bridge. Here I have added a picture. You can see that how these bridges works and how these are constructed. So this is a typical truss bridge. So you see that a span is coming here. This is the anchored span. This is the suspended span, and sorry, this is the cantilever span, and this is the suspended span. So a span coming from the left and a span coming from the right, and a suspended span supported by these two spans. So these bridges are constructed in such a way that in the beginning they act as a cantilever structure, but when the whole structure is built, the structure configuration changed from the cantilever to a continuous beam. So this is the basic concept behind these bridges. Okay, this is a schematic of a basic thrust arch bridge. So in the thrust arch bridge, what the basic concept is that a parabola or a circular section is provided. So the loads are resisted by the arch action of by the arch action. So in the thrust arch, the horizontal and vertical reaction are supported at horizontal and vertical demand are supported at the reactions. We have other variants of this as well. These are the three variants of the thrust arch bridge. This is a three hinge. So a three hinge basically is a determinate structure. This is a sorry, a two hinged arch. It is an indeterminate structure, and this is a fixed end arch. So the support condition the depends upon the load coming and the scheme that the structure engineer decide. This is also another version of the arch bridge. This is a tied arch bridge. So in the thrust arch bridge, the horizontal reaction is supported at this support location, but in the tied arch, the horizontal component of the load is transferred to the superstructure or to the deck. So either the deck act as a horizontal compression supporting member, or some ties are provided here to support the horizontal component of the load coming from above. This is also another variant of the tied arch bridge. Okay, this is a basic schematic of a suspension bridge. So in suspension bridge, it is one of the most efficient type of structure, and spans up to 2000 meter has been built with I believe the Aikashi Kyoko bridge in Japan is built with a suspension bridge with a span of 1990 meter. So suspension is a very stable system, and the principle is very basic. So these cables, first of all, these towers are built and the cable are placed. So and then the superstructure is suspended from this suspension cable. So you can see how the load transfer occurs in this type of structure. So So the load is transferred from the deck to the suspension cables, and these suspension cables transfer the load to the anchorage system, and the vertical component is transferred to these pylons or columns. This is another variant of the suspension cable system. This is a self-anchorage or self-anchored suspension system in which these anchorages are not given, and the deck act as a as an anchorage, just like this tied arbis. So the horizontal component is transferred to these superstructure. This is another version of bridges. This is a cable stayed bridges. So in the cable stayed bridge, as you can see that it is basically a cantilever type of structure. Just like the truss bridges, we have a cantilever span and a back span. So this is how the force transfer mechanism occurs in these type of bridges. This is another type of variant of this bridge. This is the tower stabilized. So in this type of bridges, the supports act the support transfer the horizontal and the vertical component, and the tower just act as a vertical reaction, uh, provide the vertical reaction. But in this tower stabilized system, both these the whole structure is resisted by a couple created on the towers, and this is how the force transfer mechanism occurs in such type of bridges. This is a hybrid bridge, and as you can see that in the span near to the support, uh, a cable state structure is used, and at the mid span we provide suspended spans. So these suspended spans support the mid span, and the edge span are constructed in a normal balance cantilevers type of construction. So these are this is a typical a schematic of a hybrid structure. Okay, so the next portion is component of bridges. So this drawing shows some of the components. In the next slide we will see some other components. So this is a basic overview of what the different type of support of the bridges are. So as you see that when you proceed to the bridge, we start with the approach slab. So the function of approach slab is proper transition of forces, or proper to provide a smooth transition for the vehicle, because if somehow this soil fails, so when the vehicle comes and it will suffer, it will suffer a shock or a jerk here due to the settlement. So we provide an approach slab so that if somehow this soil fail, this approach slab provide a smooth transition from the road level to the bridge, and this approach slab is supported by this back wall or this abutment wall. This is a typical girder. This is a deck slab, and we know that we provide expansion joints in bridges. This is a typical span of the bridge. You can study this for yourself as well, and if someone has any question, they can ask later or in the next class. This is also another drawing which show the different components of the bridges. So you see that these are a typical span, these are battered pile, or these are common pile. This is a pile cap. This is known as in some literature it is referred to as bent, and in some literature it is known as transom. So we in Pakistan usually call it transom. This is abutment. These are the wing walls. So we will discuss in the substructure component what is the function of these different components. But this is a very brief. We cannot go to detail in every components. You guys